mode.
Hi, thanks for coming to the webinar today. I'm Matt Cederberg, the CEO and co-founder of T-Splines Inc. The co-host today is Fernando Rentas, a 3D visual artist and V-Ray trainer. And thanks for taking part of your day today to listen as we talk about how to change your approach to design with T-Splines for Rhino and V-Ray for Rhino. So let's just take a look at the agenda for the webinar. First of all, we'll just give a brief introduction of both the T-Splines plugin and the V-Ray plugin for Rhino. Then the bulk of the webinar will be giving a live demo to actually show how to start from scratch to design this knife that you see here in the corner and model that with T-Splines and then render that using V-Ray. Throughout the webinar, feel free to ask questions by typing in the questions box on your GoToWebinar window on your screen, and we will try to type back and answer questions in real time, and then we'll also make some time available to answer those questions live after each portion of the webinar. And finally, this webinar will be recorded. So the purpose of the webinar is to show how to use these workflows in T-Splines and V-Ray to model. And our hope is that after the webinar, you'll have enough understanding to be able to do that yourself. But if there's some small parts of either the modeling or the rendering that you didn't quite catch, don't worry about that. We are recording the webinar, and you can access this online later to watch again. So we'll just go ahead and break into the overview. T-Splines for Rhino version 2 was released just last month, and it's a plugin that can be used to create organic designs, edit them quickly, and then export them for manufacturing without remodeling. And V-Ray for Rhino is a high-quality photorealistic renderer. All of the images you see here on the screen were designed using T-Splines. Some detail, in some cases, was added with just Rhino, and then V-Ray was used to render these. So you can see some of the, if you design any sort of designs with organic elements and then need to create impressive renders, and these are products that you might want to consider. I'll focus a little bit more on T-Splines now in this part of the webinar, and then Fernando will introduce V-Ray. But again, the three main benefits that T-Splines brings is the ability to create smooth organic designs, edit them quickly, and then export them for manufacturing without remodeling. During the webinar, we won't talk much about the final point, exporting for manufacturing. Just in short, the way this is possible is that T-Splines are fully compatible with NURBS, which are the standard surface used in CAD. So any T-Splines model can be exported to NURB surfaces and then can be manufactured however any Rhino NURB surface can be manufactured. But we focus today on just the actual creating of the organic designs and editing them. So there's two ways that we can kind of create an organic design. First is by creating the design completely in T-Splines. So here's an example of this earring that was designed just completely in T-Splines and then manufactured. This is a complex surface, but this is still editable. Any point can be moved without any gaps or sliver surfaces appearing. The second way to use T-Splines in design is by creating a hybrid, so creating the main organic shape of the T-Spline in T-Splines, and then converting it to NURBS and adding in the finer details, the fillets, bosses, trims, and that's a way of combining T-Splines and NURBS, leveraging the strengths of both T-Splines and Rhino to create an organic, detailed shape. There's three main workflows for creating a T-Spline. The first is to start with a basic shape, so either with a primitive or from some lines, and then push and pull on the surface created until you get a complex surface. This is also known as box modeling, and is a popular method used in the animation industry. T-Splines is bringing this method into industrial design for the first time. Other ways of creating T-Splines includes from input curves, so either from lofting or by skinning a non-rectangular network of curves to create an editable T-Spline surface. And then also you can convert both untrimmed NURBs and OBJ or other meshes to T-Splines. You can learn more about all these workflows at on our website. We'll just click here to show you the link. There's a user manual available, and that's accessible just by going to the top in support and going to the Rhino user manual. And this is free, and you can download this to get more detail about basically everything that we're telling you today. Also on our website you can get a free trial of T-Splines, and go visit our forum or get other tutorials there as well. The workflow that we'll be focusing on today in this webinar is this very first one, where you start with a primitive, then push and pull on the surface to create a more complex model. So the demo that we'll be doing is how to model this knife using T-Splines, and the overall workflow that we'll be following is first starting with a reference image. In this case, we have some 2D curves. Then create a primitive, like a box primitive, and just kind of put that near the lines. Then push and pull on the control points until you fit the primitive to your reference image. Finally, add some more geometry to get more detail to the model, and then finally you get your final surface. So with that overview of this box modeling process, let's jump right into the demo and show how to use T-Splines for Rhino. So here's the final model that we're creating. If we just go to shaded mode, we can see some of the detail. Some transitions here. This is two surfaces. Here's this is one T-Spline surface here, the grip, and here's one other T-Spline surface, the rest of the knife. We can zoom in to see some of the local detail that's teed off here with T-junctions, T-points, and that's C2 smooth there. And then we can even see where we have the sharp crease here on the knife. That's perfectly sharp, C2 sharp, and then it dies off to being C2 curvature continuous smooth on the rest of the knife. Let's go ahead and turn off that layer and start modeling from scratch. So you can see my setup here. Here's just Rhino 4, and then I have the T-Splines toolbar here on the side. And to start off, just as we showed in the overview, when box modeling, you start with a primitive. So we have 6 T-Splines primitives. We'll start with a box primitive because that most closely shows the shape of this knife. And then we'll just change here in the command line the number of faces in some of the directions so that we have enough control points to work with in the model. We'll also turn on symmetry because this knife is symmetrical. We'll turn on symmetry in the x-axis. And then we will just go ahead and place the box. And we don't have to place this exactly how the knife will be. We just have to get it kind of close because now we'll be moving control points to get it into place. So here's a T-Spline box. You can tell it's a smooth surface just like NURBS. The green shows the symmetry boundary and the symmetry axis. And then when we decide to, when we're working with the T-Splines model, we can either work with it as the smooth surface, or we can use the smooth toggle command to toggle it to what we call box mode. And I'll start out working in box mode because this helps me visualize and see where my faces and edges and vertices are a little bit better than the smooth mode. One other T-Splines feature that I'll use right now as well is the edit mode. And this can be accessed by clicking on the manipulator icon. But whenever the edit mode is active, you can see this heads-up display in the corner of your viewport. And this is something that T-Splines introduces into Rhino. And what it gives you is, first it gives you manipulators. So we have both a translate, rotate, and scale manipulators you can use to scale your objects. Also, you can change the selection mode. So you have object mode, vertex mode, edge mode, and face mode. And those are all different components of the T-Spline that you can move around to shape your model. So we'll start out by going to vertex mode, and we'll use the translate manipulator. And the first thing to do is just to move these control points into position so they are kind of representing the curvature of the model. So move that over there with the translate manipulator, then we can click here to go to the scale manipulator, move the control points down. And we'll do that. Then we can do that with these control points. By dragging this disk, it will constrain the movement to a plane. Scale that down, translate. Translate these guys over, scale. And one thing that will become apparent if you're moving a lot of control points is that it's kind of inconvenient to need to move over here to toggle the manipulator by clicking on that. So there's a few things you can do. One is you can pull out this toolbar and just change your selection from the toolbar. So that's one thing that kind of speed up the process of switching between the manipulators. One other thing you can do, though, is use hotkeys. So you can tell that when we have edit mode on, then hotkeys are enabled. We can disable or enable them by clicking this blue text there. But by going to the T-Spline's options, we can look at the hotkeys that are enabled. So we have hotkeys assigned to the manipulators, to the different selection modes, mesh settings. And you can also assign any T-Splines command to a hotkey. So we can assign extrude to the hotkey X and just assign that. You can also assign any Rhino command to a hotkey. So I'll just type the zebra command and assign that to a hotkey here. And so whenever you're in edit mode, then these hotkeys will work assigned to those commands. So now using the hotkeys, and I'll just hit the W hotkey and move this into position, and then hit the R hotkey to scale, and then W again to move, R to scale. And you can see how that helps me get these into position a little bit more quickly. So now I'm just using the hotkeys and moving the control points over here. Here's the last one. Okay, so now that we've kind of got these in position in the one view, the way to start out box modeling is to first work in one orthogonal viewport and then move to another orthogonal viewport. So now I'll move to the top view, and we can, let's see, maybe first I'll toggle to the smooth mode so we can see how this is looking. It's kind of gradually taking shape, but obviously this blade of the knife needs to be a lot skinnier. So I'll toggle back to the whole mode and just grab these control points. And since it's symmetrical across the y-axis, we only have to move the control points in on the one side, and they'll update on the other side. So just moving these control points in to make this a lot skinnier. And again, we'll toggle back to the smooth mode and see how that's kind of forming our model. One benefit that T-Splines has over NURBS is it's really easy to explore different design iterations. So as I'm looking at this and looking at how this model curves around here, this is very uniform, and I think I'd like actually to have some tighter curvature here on the top of the knife handle, and then have it smoother down here. And the way to get tighter curvature with T-Splines is exactly the same as with NURBS, and that is through positioning control points closer together. So by moving control points closer together, I'll have some tighter curvature up here. So I'll work on that in the right viewport. We'll go back to whole mode, and just move these control points up closer to the other ones, and we'll get some tighter curvature. So to have this stay uniform across the whole top of the knife, I'll move all of these control points up to the top with this row of control points. And then, because on the handle I want some even tighter curvature up there, I'll move this second row up very close as well. And we'll just do this part here on the handle. And then take a look at this in the perspective viewport. Hit the smooth toggle button. And you can see how that, now I have a lot tighter curvature up here and it smooths out there on the bottom. So we can play around with that just by moving the control points. Let's see. So at this point, I think we'll probably want to go ahead and pull the model out so it's actually touching the box mode, and switch over to edge mode now. And just select this edge and drag this disc to constrain the movement to the plane. Pull that out and then hit the R hotkey to scale this down. And back here again, we'll stay in edge mode and just grab this edge and go back to translate manipulator and pull that down. You can see whenever we're in edit mode, we have pre-selection highlighting T-Splines. It's different than the normal right-hand highlighting. It makes it so it's faster to select items. So let's go back to the smooth mode and see how our model's looking. Looks like we still need to pull that out a little bit. But before we really do some more control point moving to fit the model, let's just kind of look at the general shape of the model more. This blade we want to be pretty straight and sharp, and with all the control points and edges we have here, it's really kind of curved, and so that means we have more detail than we want. One benefit that T-Splines has that's unique to T-Splines that's not available on NURBS is the ability to delete local isoparms or local edges in the model. So I'm just selecting these edges, then I'll hit the delete icon, and that will just delete. Oh, let's see. Oh, I had the wrong select. Let me undo that. Let's see. Undo that one more time to bring back symmetry. Let's see. Okay. Let's go back to smooth mode and select the edges. Okay, let's try that one more time. And delete these guys. Then we will also need to delete these control points so that it can go back to smooth mode. So hit delete one more time. And going back to smooth mode, we can see now we have this detail just teeing off here, and there's less detail here at the front. So that will make it so it's easier to keep this a little bit straighter with not as much curvature there. We'll have the knife blade. Okay, so now that we've got the number of control points correct, we'll do a little bit more finessing of the model. Looks like I undid this, so I'll go ahead and pull this back out. And then just we can play around a little bit more with just the general look of the model. So we can select faces in T-Spline, so we'll go ahead and select these faces and pull those down to change the curvature. Select these edges, so we can pull those in, pull these edges up a little bit, and we can just continue it however long we want to just kind of play with the curvature of the model. But that's looking pretty good. So now we'll come back down here to the right viewport, and in smooth mode, we will go back to the control points and move the control points into position so that they so that we kind of tightly follow the outline of the model. And with T-Splines, just like in NURBS, the influence of every control point goes on to the next two control points over. That's how the surface is able to stay smooth. So that's why as we're moving this, you can see the shape changing smoothly outside of just that control point as the surface kind of updates to stay C2 smooth. So let's see, let's move these around. And move this guy up. And we can, one advantage of doing this with such a small number of control points is it's easy to keep the surface nice and fair. So as we're moving that, that's one thing that's being maintained. Move that down. So let's kind of work our way across the model and getting these control points into position. Let's kind of zoom out and take a look to see how that's looking. Okay, that's looking pretty good in general. Let's see, we should move this guy down. One area that has a pretty high amount of curvature that we won't be able to achieve with just this number of control points is this transition right here. And in order to match that curve, we're going to need to add some more control points. So just as in before, where we deleted some edges in the T-Spline model, T-Splines also lets you add local detail. So we'll use the insert edge command and just select this edge and just click where we want to insert that. So we'll insert that here. And so now we have some more detail. So when we go back to the control points, we can move these control points up into position. And now with that extra control points, we have enough detail to really get that curvature. Okay. So that's probably good enough. We could continue to play with that, but looking here in perspective, that's a pretty decent looking knife now that we have. So now we have the basic shape of the knife done. Now we'll go ahead and add some more detail to add the grip to the model and to prepare to add the crease here. So for adding more detail, we'll go to the mode. Then what we're going to do is subdivide T-spline spaces. And there's two different options when subdividing. You can do the simple option or the exact option. We want the exact option because we've spent so long getting the model looking how we want it. We don't want it to warp. So with this, when we do it in the exact, then it will disable symmetry, but that's okay. And if we toggle back to smooth mode, you can see that the surface actually has not changed. It's just added some more detail. We'll go ahead and add some more detail again just here where the crease is because we want to have some fine control over that crease. Again, you can subdivide both in smooth mode or home or box mode. So now we've added more detail there, and you can see the surface didn't change. So now with this added detail here, we'll go ahead and add the grip. First, what we'll do is we'll extrude inward so there's a place for the grip on this model. So I'll go ahead and switch back to box mode and just select these faces, and I will extrude them. So let's hit the extrude command. And after I extrude, now I'd like to move them all inwards along the normal, so I can change my manipulator. There's some different manipulator drag modes. And now I'll go to the UVN mode, and by just dragging this blue manipulator, you can see that this will extrude inwards along the normal. And you can see when it's extruded, and there's this row of faces that's added. So I can extrude that just freehand, or I can undo that, and by hovering and clicking on that manipulator, I can enter an exact distance. So I'll move this in -0.1 units. You can see how it will move it in exactly that distance. Now let's go back to the smooth mode and see how our model's looking. After that extrusion, you can see how it's changed the shape of the model, but it's kind of a washed out extrusion. What we'd like is really a little bit tighter control there. So we'll undo this, and just like we did before when we wanted more detail, the way to get a some tighter curvature is just by adding more control points. So we'll go to edge mode and select one of these edges. Then we have some paint selection tools in T-Splines that help you select a lot of things quickly. So there's this edge ring command that will select all of these edges in this whole edge ring across that whole extrusion. We can use the same insert edge command that we used earlier to add some more detail. So I'm right-clicking here, and I can freehand by just inserting detail wherever, or I can type in an exact percentage. So I'll just type in 0.9, and so now there's some detail added here. And now when we go back to smooth mode, you can see how that's a tighter curvature there, where we have the outline for the grip. So now the main part of the knife is ready for the grip. Now we need to make the grip itself, and the fastest way to do that will be to go back to mesh mode. And go to face mode. Let's see. And select these faces. Go ahead and hide the manipulator. And with these faces selected, we will use the duplicate faces command just by right-clicking on this icon. And we'll duplicate all these faces. Now to see what we have going on, we'll go ahead and hide the main knife. And so you can see we've just duplicated this part of the knife where we'll have the grip. This is the T-Spline surface now. We can go to smooth mode to see how that will look. So if we want to turn this into a volume and add some thickness, then we can thicken this. And we'll just use the T-Splines thicken command. Click on here, and we can freehand the thickness, or we can again type an exact distance. So we'll type in 0.1, since that's how deep we have made the extrusion.
Yeah.
And get the right direction.
Is it your?
And so now we can again toggle back to smooth mode to see how how that's looking. We probably want this to be a little bit fatter here, so we can add some more detail. So we'll do that. So we'll go back to our same trick of grabbing an edge, selecting the edge ring, and then doing the insert edge command. And again, we can either, this time we'll go ahead and freehand inserting that, with that there, and then just hit spacebar to repeat the command and freehand that there. Then hit smooth toggle, and you can see how there we have this turned into a solid. It's still editable. We can still use the manipulator to move any of this parts, but that's a solid now. So now I'll go ahead and unhide the main part of the knife. Switch that over to, switch this over to smooth mode. And you can see here's what the knife is looking like. So there's the grip, there's the main part of the knife. And the last thing to do is to add a crease here along the blade. And with T-Splines, we can add perfectly sharp creases that are C0 that blend into the rest of the surface. So we'll just use the crease command. And I think I'd like to go to the box mode so I can more easily see where my isoforms are. Go back to crease, and just select the edges that I want to have creased. So I'm just selecting them all here on the bottom of the knife. And go ahead and hit enter. And we'll go back to smooth mode to see what that crease looks like. And you can see, again, it's perfectly sharp, and it will just die out into being perfectly smooth here in this part of the knife. You can still, even with that crease, you can move any part of the T-Spline surface. You can move edges to change that, move control points. And at this point, you can render the model. You can export it to NURBS. We'll just show what that export looks like. I'm just hitting escape to leave exit mode. And converting T-Splines to NURBS, you just right-click on this convert button and click on the T-Spline surfaces, hit enter. And then we'll just show without the surface isocurve. So you can see that when T-splines are converted to NURBS, the shape of the T-spline does not change at all. It just splits the T-spline out into these NURBS patches, because the NURBS have to be rectangular. So that's how to model a knife and T-splines using the box modeling method. Let's see. I don't know if there's any questions at all that we need to answer before we move on to V-Ray. So let's see. Tom, are there any questions that you have not answered yet? Let's see. I'm just looking through the questions. Roy is asking, how correctly will the surfaces of these parts touch? So Juan, do you want to go ahead and talk to that? Are you online? So the question is, how correctly will the surfaces of these two parts touch?
Well, it's going to depend on how many control points you put. If you want to perfectly touch each other, you have to insert more control points there, but they're perfectly touched. In this case, this model is it's just a rough for visualization, but you can make them match perfectly.
Okay. Yeah. So as Juan was saying, the answer is that depending on how many control points there, you can get it to within any accuracy. So if we had some more control points, we could get these tight within the tolerance that we want. Let's see some more questions. At the 5 star points, will the continuity of the surface curvature be uninterrupted? That's a great question. So here's these are what we call star points. I'll go back to T-splines. This is here we're in NURBS. We'll go back to T-splines before we converted it to NURBS. Here at the star points, the surface is G1 smooth. So everywhere else, even at these T points, the T-spline is C2 smooth, and here at the star points it's G1. So that's good enough for the surface to be offset. We can go ahead and shine some zebra on here to show how the surface smoothness there. But there you can see the star points there, and there's how the zebra's looking. So let's see some more questions. Which is the toolbar on the right panel? Let's see. I don't know if I quite understand that question. Do we have to give layers before moving to rendering? We'll let Fernando talk about that. Will O-snaps work with T-splines while moving the vertices? Yeah, O-snaps will work. So you can snap a T-spline vertex to go ahead and turn on O-snaps. Let's see, exit zebra. And so here's a T-spline vertex. We go ahead and move that. You can see that it's I'll turn on point snap, and it will snap to the control points. Let's see okay, someone didn't understand the difference between the arrow for the spot of the manipulator, and I hope Ren. So with the T-Splines manipulator, there's 2 ways of using it when you're in the arrow. One is just freehand, so you can mouse over it and move, and you can just kind of freehand it. And then the other way is if you actually click and release. At that point, you can enter in an exact distance. So we can enter in like 2 units, and it will move those control points exactly 2 units. So that's the 2 different ways of using the manipulator. So a question back when we were deleting edges, is it simple to bring those edges back if we delete edges? I think that may have been answered later. We can just insert edges using the insert edge command. We can also use the insert point command. That's another way of inserting points. So if we wanted to add some edges here, we could just click there, bring the edge up there, hit enter, and that's another way of adding edges to the model. Okay, looks like those are the questions. We'll go ahead and answer all these questions as well as in an email that we'll send out. But we'll go ahead and turn the mic over to okay. Oh, I guess one more question: will the presentation be available later online? Yes, it will be. Another question that came in: can the NURBS be converted back to T-Spline, say after we've saved the project without using the undo? We'll go ahead and show how that works. Go ahead and undo the last couple of steps. When we convert this to a NURBS, you can see it's a whole bunch of rectangular NURBS, and we can go ahead and explode that to see how it's just a whole bunch of smaller rectangular NURBS. We can convert each of these NURBS back to T-splines. So here's a rectangular NURBS. I'll just click this to convert that back to T-spline. And you can see the conversion doesn't change, but the problem is all of these surfaces are they're all separate. So you can convert all these separate surfaces back to T-splines, and then you can merge them together inside of T-splines, but that's kind of a hassle. So going from NURBS to T-splines after you've gone from T-splines to NURBS can be done, but it is a bit of a hassle.
It's probably a good idea just to save the T-Spline, because when you save the T-Spline, it also saves the NURBS. So if you give a file to someone that doesn't have the T-Splines plugin, it'll just open up as a NURBS, and Rhino will be able to work with it.
Okay, yeah, thanks for that, Tom. Okay, we'll go ahead and turn... okay, so someone clarified this. Yeah, this is the toolbar. This is the T-Splines toolbar. That's what this is. This is the T-Splines Rhino toolbar. That was a question. Okay, and then there's one final question. Do we have history to keep every move, like Photoshop? Tom, do you understand that question?
We don't work with the Rhino's record history, like at the bottom of the Rhino window there. And what we do is we just work with the Rhino's undo mechanism for undoing individual, popping them off the undo stack.
Okay. Okay, well, we'll go ahead and turn it over to Fernando, and if there's more questions that come in, we'll answer those in an email later. So go ahead, Fernando.
Okay, thank you, Matt. Can spend a few seconds to change the screen. So everybody can see my screen right now. Damien, can you see my screen?
I'm just getting a splash page right now.
I think
Okay.
I can see it.
Okay.
Okay. I just got it, Fernando.
Okay. Thank you. I have some the same type of math modeling in the T-Spline presentation, and also I have some wood plate there that Juan modeling for me. So thank you, Juan. Also, this toolbar here is a T-Spline toolbar as well. So you can change the toolbar. I don't know, probably Matt you can change to have the test, the toolbar with the test, and just the toolbar without the test. So I have the toolbar without the test. Let's go start make a render just with our default setting. I have two cameras. I would prefer to render this camera here. Let's make a render with our default setting. I'll just change the dimension of the V-Ray frame buffer to match our view, but this is a render that you get with our default setting. And we are going to create a few materials because our render should look like this guy here. So I will create a dark wood material, light wood material. We need the plastic for the handle and steel, brush steel for the blade, and also another kind of steel for this little sharp edge here. So let's start create the wood material. Let's start to create the environment. Right now, I will open the V-Ray option here in this the second button. I'm gonna use HDRI to illuminate my model. So in the environment, we have two main options. One is the GI skylight. It's about how illuminate your scene, and the other one is about what you see on the background. So I'm going to select the GI M and select the bitmap in type. I'm going to select an HDRI to illuminate my image. So I have two HDRI here that you can download on the Aversi's homepage. Those HDRIs are very common. So I will try to keep the rendering part as low as basis as possible. So I have two different HDRI, one a blur for the GI and one very sharp for the background. So I'm gonna use the blurry one for my GI. I don't need too much detail to illuminate my scene, just the area where the light are. Also, the HDRI are images that contain light information. So if I click the preview with the texture options, I can see that my whole HDRI. I'm using an HDRI called mirror ball HDRI. It's because it's like taking a picture to a mirror ball. So I have to change my UVW to environment in order to use this HDRI to wrap around my scene. In the mapping type, I will use mirror ball because my HDRI type is mirror ball. So I select mirror ball and I click preview. Now you're gonna see another preview there. I'm going to apply and I will create another render test. I disable my calculation. I'm sorry, I am using a TSpline. That's why you see a bunch of square there. It's because in my system I'm using a TSpline in order to speed up my render, because we don't have too much time for this section, so I'm trying to use more than one computer to render. And this is the illumination that I get with the HDRI. So you can see more contrast here, the shadow here, and this is very good to illuminate your model. Let's create some material. The first thing is for the metal, I've downloaded my steel brush through our web page. So if you want to download some material, go to software, download, and then in material here you can download material, and I'm using the metal. For the blade, I'm using brush material, brush metal, this guy here, brush stainless steel metal. This is the material that I've used for the blade. Okay, if you want to use the same material that I use, just download from our web page. Okay, first thing I will create a wood material. So right click in the scene material, select add material and V-Ray material. Change the name to bamboo dark. In the diffuse, I will select a bitmap that match my bamboo texture. So select bitmap in the type, and then click in the small m in the bitmap and select the bamboo texture. I have one here, bamboo dark, so I'm going to use this one. If you select preview, you can see the material in the preview windows. Select apply, and also if you click update preview, you can see the material in our material preview there. I just want to right click and apply the material to the object. Now you can see how the material is already applied to the object. I have one mapping texture, a texture mapping enabled in this bamboo table, because I want to specify the location of my bamboo. So this is the mapping widget. So I already have the texture mapping enabled with some scale and some position. So you can move the mapping widget and change the orientation, rotate the mapping widget, and you can rotate the orientation of the texture. So let's go back to my original one. So it's this guy here, and this is my mapping. So I want to create some kind of reflections in this material. So I will go back to my material editor. This is the first icon, the V-Ray toolbar, and then right click on the reflections and select add reflections. Our material system is a layer system, so the layer have a position, and those positions are very important right now, because in order to see through the layer, you have to apply some kind of transparency. Right now, my reflection layer is like a coating, a clear coat over my texture, so I don't need any transparency there. But I want to create if you click preview, now you can see some kind of reflections in my material. But I don't want a perfect reflection. I want a kind of blurry reflections, so I will add highlight glossiness and reflection glossiness in my material in order to blur a little bit the reflections. So I'm going to use 85 in both options in order to blur a little bit the reflections. And I will make another render test. And now you can see my material already applied.
Fernando?
Yep.
I think you forgot to map the background as well.
Yes. I will map the background after the created material.
Okay.
Yeah.
Sorry.
Yes, but yes, I'm not. I forgot to apply that. Then I will create the light material. Now you can see it right now, a kind of reflection here. But thanks, Damien. I forgot to apply the material, but I want to see the render without reflection, without the environment, and with the environment, in order to show you the difference between the HDRI in the background and render without HDRI or without nothing to reflect it. Right now, because I don't have any reflections image in my background is completely black. If I turn my render in this way and I make another render, you're gonna see the black background. In order to create see, my background is completely black. That's why I don't have any object to reflect, just a little bit in this area here and the floor in the wood. Okay, in order to create I just want to add a little bit bump to the wood in order to create some dip in the wood. So I'm going to use the bitmap, select in the M, and apply the bitmap for my bump. I'm going to use the same version of the bitmap, but in grayscale color. Select open, and I want to decrease the bump size to 0.005. I don't want a very hard bump there, just a little bit. In order to create the other bamboo color, the bamboo light, the light bamboo, I will duplicate the bamboo dark, rename the material, put light, and change the diffuse mapping, because right now it's the dark one, in order to use the light one. Click apply, and everything will be the same. Right click in the material and apply material to object, and now you can see my other material there. As I said before, I already have a decal mapping, a texture mapping there with the correct position, but you can move, rotate, and whatever you want in order to fit your desired scale or something. Okay. So I make a render right now with this material. You're gonna see the word. Okay, because I download the brush material, I just want to apply it to the model. Right, select the brush material, right click, and apply it to the model. I make a small modification in this material because I want to see the texture mapping here in my viewport. So I create a 2 layer and apply with the same color, and apply the texture that I'm gonna use for the mapping in the diffuse layer in order to see the mapping in the viewport. But I put this layer completely transparency in order to don't see the mapping, to not see the mapping in the final render. So I don't want this pattern in the final render. I just want this pattern in my reflection here to get the correct color or the correct effect. But I'm not going to explain the brush material because you can download from our web page. In order to create the material for the blade, I just duplicate the steel brush material and change the color kind of lighter in order to get this color lighter than the blade color. So I'm going to apply this brush material to the edge, and the last material that I want to create is the rubber material for the handle. Double click in the add material and select add V-Ray material. Change the name to rubber, and in the diffuse color I'm going to use a dark color, kind of 40, something like that. Also, I want to kind of reflections in the handle. I'm going to apply the material right now. So I have to create a reflection layer. Right click and add reflection layer, and now I can see my layer. Because I don't want completely sharp reflections in the rubber material neither. So I decrease the highlight glossiness and the reflection glossiness kind of 0.7, something like that, 0.7. In order to blur a little bit the reflection. Also, I like to apply a kind of filter in order to tint the reflections, get some color to the reflections. And I want to apply the one color, decrease the color to something like that. Not quite, 125, something like that. Apply. The filter options will tint a little bit my reflections in the handle. Also, I will apply the bump map, but in this time I will use a noise, one of procedural type that we haven't. I will use a noise bomb here. And in order to decrease the size of the noise, I will use 0.01 in the size of the noise. You can see how my noise is very small right now. And in order to reduce the bomb, I will reduce the multiplier here to 0.012. So I will shoot another render. You see my reflection right now? I don't have nothing in my background, so that's why my reflection is completely black there. To fill in my material, I have to create the floor material or the granite material. Create material, change the name, granite, and I will apply the material to my floor. Apply. In my diffuse color, again, select a bitmap for the floor. Select the granite 1. Now you can see my granite texture in my viewport. But I want that my granite material will be reflective, so I have to add the reflection layer again. And I want to apply some bump here in the granite, so I select the bump and select the bitmap and select the bump map. Same version but the dark grayscale color. And I will reduce the multiplier in order to having a small bump to 0.005. And select apply. And this is the preview of my material. Also, I don't want that my granite material will be very reflective or sharp, flat reflective or shiny, very shiny. So I want to apply some blur there using the highlight glossiness and reflection glossiness to 0.85. And now I believe I have all my material there. I'm going to click render again to see my material. Now you can see all my material already applied, but I don't have any cool reflection here because my background is black. So I want to use the same SVRI version in my environment. Same thing, environment, a mirror bulb, and then apply the same SVRI but a sharp version. Now you can see the SVRI, but I have to change the type to mirror bulb. Now you can see the person that take the picture here in the environment because it's mirror bulb because this guy take a picture to a mirror bulb in order to get the environment. So let's apply and make a render again. I'm going to stop the calculation here because I want you see the final render, the difference between both. It is rendering, but I hide the calculation right now in order that you can appreciate the change when you have something to reflect. Now you can see the reflection is very nice in my wood, also in my floor and in my knife. But it's very hard to get the desired contrast just with the HDRI. So we recommend use HDRI in combination with other light. So I create a new, another rectangular light have the rectangular light in the light layer. So I create another rectangular light in this area in order to get more contrast in this area, in the handle area. So that's why I place my light there. So I'm going to increase the size of the model. Something like that, and make my final render. It's still rendering. Oh, sorry. I know we need the log view options. There we go. This is pretty my part in the V-Ray rendering. So you can apply material. You can use an HDRI for illuminate your scene. Also for the reflection, the same HDRI version, and combine it with some rectangular light in order to get the desired contrast. Again, this is the final render. You can see the contrast in the handle and in the blade, and the different material between the blade and the edge here. So this is the final render. Also, I appreciate for being here. And Damien, can you say something?
I don't know if there are any questions, Fernando. I can't see the questions over here on my screen. So are there any about your specific?
Let me see the question. How many distribution computer are you using for the rendering? I think I'm using 10 computer with 8 core, so 80 core plus my 2 core. Is a subscription required to access the material library on the website, Damien?
You will have to log into the website. Registering at asgviz.com is free, and then once you do that, you can download all the materials and VizOps and things like that.
Okay, I have a question here, another one. Which unit does bump use? The bump mapping?
Bump mapping references whichever is your scene units. So if you're modeling in millimeters, for instance, you probably won't need as small of a bump map as Fernando is using. Fernando, I believe, modeling in inches, or at least his scene is in inches.
Yes.
And so typically that's a much lower bump map that's needed. Bump maps are not exactly a sort of real-world 100% value. They're just kind of a reference. So it's with a smaller scene unit, you won't have to decrease the intensity of the bump map nearly as much.
Okay, the setting that I was using for the small render are pretty the same setting of our default setting. The only difference is in the minimum and maximum rate for irradiant map. I'm using -4 and -2 for the test. Okay, let me see if I have no other questions. He said, can you tell me the best web resource for V-Ray material, free and pay? Are there any dedicated sites similar to www.vray.com? Damien, do you want to answer the question? If we know,
we just got our material site back up. So if you haven't checked asgviz.com in a little while, go back and check a number of the materials that we have there. Also, there are a few other online resources. One is from one of our users, but I don't have them right in front of me. So we can send those in an email. There are about 3 or 4 different material websites out there that are good resources.
Okay. How setting you use for the final render? How to eat the super fine pixel? Okay, I have this toolbar in my left. This is a new version of V-Ray Express, but it's pretty the same setting of the old V-Ray Express toolbar. If you send me an email, I can send you this toolbar to your personal email. I can post this toolbar in the web because this toolbar was made by me, and also was made by Hive. He take our idea of V-Ray Express and customize this V-Ray Express toolbar. So I can send you the toolbar if you write me an email to try to put in the chat. My email is fpdrogo@asgviz.com. I put my email in the chat. A question about this rendering, Damien. I see you use send to each node. I have problem with the send to share folder. Can you elaborate? I don't know if I understand the question. I see you use send to each node. I have problem with send to share folder. Can you elaborate? This is a question.
There are 3 different modes that are sort of used with assets when using distributed rendering. Without sort of any of the asset collection on, V-Ray will assume that all of the files are in the same location on each machine. Most of the time, that's not the case. So the easiest option is the send to each node, which will send all of the images and any sort of saved light caches that you may have to each node each time that you press render. When you have you send a shared folder, V-Ray will copy all the assets to that folder and look there for any images or maps that you may have. And so it's important that that shared folder is visible to all the machines that you would use in the rendering. Because if it's not visible to any of those machines, it won't actually be able to see them. So it'll assume that they're lost and then render on or off buttons.
Okay, Damien, I have another question here. In large architectural model, I'm regularly experiencing crash of Rhino and V-Ray. The program jam, the RAM, and then it crashed.
Can you read the first part of the question again?
Yes, in large architectural model, I am regularly experiencing a crash of Rhino and V-Ray. The program jammed the RAM, and then it crashed.
Okay. With large scenes, you have to be pretty careful about how you're modeling and what you have available. So typically, yeah, that first question in our frequently asked questions is a really important one, especially within Rhino, because you can have a very simple NURB surface, yet a very, very dense mesh. And so a lot of the times, reducing the mesh settings for the scene helps quite a bit. There are also a few other tips. You can actually pre-mesh the scene, and so you can have a copy of the scene with just the mesh information. This makes it a little bit easier, or frees up a little bit of room memory-wise. You can also decrease the size of your textures for ones that don't need to be very large.
Yes, I have a question here. Which is the size of my texture? My texture is 1,000 by 1,000, 1,000 by 1,000 of the texture size. I have another question about this blue icon here. This blue icon are my personal icon. So I have all the Rhino command customized in this icon. All my line are here, my curve are there, all my curve tools here, curve on surface is here, surface tool. I have all the toolbar attached to this bar. So I can send you as well if you send me an email. It is possible to get V-Ray for SolidWorks, Damien? Damien is our program manager. Also, he is a V-Ray expert and trainer. Damien?
At the moment, there aren't any specific plans for V-Ray for SolidWorks. I mean, we don't really have any sort of timetable for that right now. So, no V-Ray for SolidWorks at least.
Okay. Another question, Damien, is Rhino. Is there a limit of 3 gigabytes of RAM in Rhino in general? And if so, will that be fixed in Rhino 5?
The memory limitations with Rhino are they're not really due to Rhino. They're due to 32-bit operating systems, and you just get maximum amount of memory that they can handle. Right now, Rhino is a native 32-bit application, and so by default in your standard Windows installation, it will only be able to use 2 gigs. There's something called a 3 gigabyte switch. You can Google that if you want more information on it. But basically, it allows a given program to use 3 gigs. You can run Rhino 4 on a 64-bit operating system, which will allow for about 4 gigs of memory usage. With Rhino 5, they'll be releasing a native 64-bit version. And so once we begin the development for V-Ray for Rhino 2, we'll have native 64-bit versions as well that will be able to take advantage of all the memory that you have in your system. But you'll have to be running a 64-bit operating system like XP, x64, Vista 64, or Windows 7 64-bit later down the line.
Okay,
So,
okay, thank you, Damien. I will ask 2 more. We're going to ask 2 more questions. Those additional toolbar are lights toolbar for lights, and this is for hide the calculation. But the main toolbar is this guy here. This is Omni Light, rectangular light, direct light, just light. Damien, one more question to finalize the webinar is when V-Ray for Mac, when? Can you hear me, Damien?
no, you dropped out there.
Okay, there a question here. When we are be available, V-Ray for Mac?
V-Ray for Mac for Rhino? V-Ray for Mac for first time. Right now, we're working actually on porting, getting a Mac version of V-Ray for SketchUp running. So a lot of the issues of getting just V-Ray to work on a Mac have already been sort of worked out. We are waiting for some information from McNeil about developing specifically for the iRhino, or Mac version of Rhino. So we're still kind of waiting to see on that. But once McNeil makes that available to developers, it's certainly something that we're going to be able to take advantage of. At the moment, Rhino for Mac isn't even a released product, so things are still changing, things are still developing, so it's hard to really kind of say exactly when and how that's going to work itself out.
Okay, thank you. I want to say thank you to Matt and Tom and Juan Santacono to share this webinar with us. I was very excited to keep this webinar together, and I appreciate the opportunity to share this webinar with you guys. Thank you a lot. Matt, you want to say something at the end?
No, just thank you very much for attending, and we will email everyone. We had a question about how this video, and it will also be available on our website. So.
Yes, absolutely, yes. I will convert this video right now to Windows media and put in the internet as soon as possible. Also,
Okay,
you're gonna have a copy, Matt, that you can put the video on your website too.
Great.
Okay, thank you guys.
Okay.
Thank you for being here and attend the webinar. Bye-bye.
Bye.